Today I'm going to be talking to you about induction, electromagnetic induction. This was first discovered by Michael Faraday in the middle of the 19th century. And before this was discovered, for about 300 years, people knew about electricity but had no idea how to generate it, how to use it effectively. And by two very simple discoveries, Michael Faraday ended up changing the world. And from that came every single electrical appliances that we use today. So what I'm going to do is I'm going to take you through some of his discoveries and how they are applied to how electricity is generated to how it's being used today. Okay? So the very first experiment, this is called the motor effect, and the idea is that all motors are basically use this principle. So over here I have a aluminium foil which I've made into a thin wire. Now the thing you need to know about aluminium is that it's not magnetic. This is magnetic. Okay, or this is a magnet, but if you pass it through it, aluminium is not one of the three magnetic metals. They are iron, nickel and cobalt. But if I pass a current through this, and this is what Michael Faraday discovered, if he passes a current through a wire, then it produces its own magnetic field. So if you turn that on for me please. You can see it's being deflected. I can actually feel the force there. You can see it doesn't want to go near the magnet. And if I now just turn that off for me please, sir. If I now just swap the current around, so reverse the direction of current, try that again. You can see it's reversed the direction of the magnetic field. So something which wasn't magnetic, if it has current flowing through it, it is magnetic. And this principle was used by Michael Faraday to produce every single motor today. So whether that motor is today powering cars, or your hairdryer, or electric windows in your cars, all of those things use this effect, which is the motor effect. He then realized, well, over here what we're doing is we're passing electricity and we're getting kinetic energy out. He realized if he gets a magnet and provides the kinetic energy himself, he might be able to generate some current. So this is a galvanometer which measures very, very little small current that's generated. And if I pass a magnet through this coil of wire, which is just lots and lots of wires turned around, if I pass a magnet through it, it generates a current. If I take the magnet out, it generates a negative current. If you leave the magnet in there, and this is the important bit which comes up in the exams all the time, if you leave the magnet in there, no current is generated. Okay, so if you put the south side in first, you get a positive current, take it out, you get a negative current. And that's all you need to know for induction. We'll go on to how this is used in everyday life. In everyday life nowadays you have a dynamo, which is basically a magnet inside a coil of wire, and instead of just taking the magnet in and out, which is actually quite difficult to produce in a machine, what other engineers, not Michael Faraday, but other engineers discovered is if you take the magnet and you just spin it, it does the same effect. It produces the same sort of current. So a dynamo would basically be connected to a magnet, and something, wind, water, or coal most of the time, burnt, heated up to steam, heating up some water to steam, is used to turn this dynamo. So that is electromagnetic induction. We'll move on to another demonstration. We'll see if you can explain this, you have understood everything to do with induction. Over here I've got copper and a very strong neodymium magnet. Okay, this is a magnet. I'll just prove that. Okay, you can see that is a magnet. And another cylinder which looks like a neodymium magnet is not a magnet. So copper, as you can see here, is non-magnetic. If I pass a non-magnet through copper, just notice how long it takes for it to come out. It just drops straight through. If I pass a magnet through copper, just notice how long it takes. Let's do that again. Non-magnet, straight through. Magnet, takes ages to come through. So the explanation for this is the same experiment as here. When the magnet is moving through the copper, it generates its own current. And as you saw with the aluminium foil, anything that has current going through it produces its own magnetic field. that magnetic field slows the magnet down. You can in fact have a look at it from the top, maybe. This is a non-magnet, just a piece of metal, and this is your neodymium magnet. You see the difference.